like you're not going to understand it. Nobody understands what deep learning is or how it works. Like nobody does. It's just a fact of the world. It just works, and we don't know why or how it works. But we still kind of reason about how things are being manipulated as they're moving through a network. Start with the fundamental, like data structure, this tensor. Kind of understand it, reason about it, and then from there you'll be able to develop some type of intuition.
Hey nerds, Monica here. Welcome to the Data Podcast for Nerds, where we get to talk to amazing professionals and ask them all about how they're using data to solve the world's problems. We're highlighting skills that data professionals use on a daily basis. Plus, we always include some fun bits because we're all nerds here and we love to have fun. So thank you for tuning in, and if you haven't already, please like and subscribe. And as always, folks, happy learning. Today with us, we have Harpreet Sahota. How are you doing today?
I'm good. How are you?
I'm doing fantastic.
Awesome to be here and on your show. After years of being a regular on the Friday happy hours and then getting a chance to meet in person in March of 2024, it was awesome. So now it's great to be here on your show.
Absolutely. I know. I'm so glad that we got to meet in person and still stay in contact. So, I mean, you've been awesome.
Thank you. You too.
We start out our show by understanding people's origin stories. So, if you could please let us know your background and how you got to where you are today in your career.
Oh man, that's it's a long story, man. Where do I even start? How much time do we have? Okay, so I'm telling you it's a long story, not because like, oh my God, because I'm 41 years old this year. So it is a long story. So if you really want the gory details, I wrote this blog. It's on my Medium. It's called, I thought failure was my destiny until I realized it made me who I was. So that outlines, the whole, gory details and stuff, but, I didn't graduate from high school on time, got kicked out, had to do like stuff to reclaim those credits. I got kicked out for the stupidest reasons. And then along with that, all my college acceptances went out the window. And then it was like many, many years of just wasting my early 20s, not learning any skills, not doing anything, and just hanging out with friends, wasting time. Finally got my act together in my mid-20s, got a degree with a 2.06 GPA in 2007, studying econometrics and stuff like that. Was a math teacher for a while. Somehow the state of California thought I was, even with that abysmal GPA, thought I would be qualified to teach math to high school students. So I did that for a while. And there's a program called Options for Youth, which is like academic recovery for kids who are essentially like me. Realized that, actually, I really enjoy math. What could I do with math that will make me a lot of money, because I want a lot of money. And this is 2008. And the number one thing that came up was actuary. And I was like, all right, cool, I'm going to be that thing. And in order for me to be an actuary, there was just like so much effort I had to put in. Like I literally had to go back to community college and start taking freaking math from like, because my horrible GPA prevented me from getting into grad school, right? So I had to like retake a bunch of classes, starting from like what's like the thing before, is it pre-calculus or trigonometry? I really had to go back and start taking math from like trigonometry all the way up through first year graduate level, like math and stats courses. Ended up with like, I did 60 units of coursework over the span of like 2.5 years. Got like, a great GPA on that, because like I'm not dumb, I was just stupid. So there's a difference between that, I guess. Did like amazing on the GREs, is that what they call it? The math GRE, like in the 90th percentile or something, and got into like every grad school that I applied to, which was great. But for whatever reason, I ended up choosing to go to Illinois State University, like the Why? I don't know. Well, I'll tell you why. Actually, because I was studying for actuarial exams, and then all the actuarial prep books were written by Krzysztof Ostaszewski, and he was the head of the actuarial department there at Illinois State University. So I was like, oh, I'll go there and I'll learn from him. Um, yeah, and so I did that. Became an actuary for a while, for like a year and a half, 2 years maybe. Passed a bunch of exams. Then met my wife, moved to Canada, moved to Winnipeg. And there were no actuarial jobs here, but there was a job for biostatistician. So I became a biostatistician because it's like the exact same thing as an actuary, but instead of um, calculating insurance premiums and things like that, you're designing clinical trials. So it's all stats, and so it was all using SAS and R and all that. Did that for like 5 years, and then got my permanent residency in Canada, which meant I can work anywhere. I hated being a biostatistician. I hated the company. I hated the people I work with. I hated everything about it. And decided I want to go back to what I wanted to do when I was an actuary, which is called predictive modeling. Found out that predictive modeling was now rebranded as machine learning. And so I had to do all that shit, like upskill. And again, for, feels like a recurring theme in my career, just upskilling, relearning, and doing stuff. And that brings us to 2018. So now I got like 7 years of history left to go. but cutting long story short, was got into data science, went from that into like, machine learning, and found like a niche within, still doing the same work, but different, interesting kind of role called developer advocacy. And that's where I am today. And I'll pause because damn, that was a condensed like 12, 13-year history.
I love it. I love it. So you, throughout your career, obviously did a lot of pivots and whatnot, and you had to upskill, reskill, and do all of that. But was there something that kind of like foundationally took you through and helped you throughout that upskilling?
Yeah. Well, I don't know if it was like really pivots, because when I think pivot, I think of like a hard shift or hard change. This is more like a juke move, like us, like, oh shit, like, boom, boom. Because I'm still doing like quantitatively rigorous work and executing that work through code, because I can't do stuff by hand. Unless you're an actuary, you do stuff by hand, which is weird, especially on the exams. But I guess that the thing that, I don't know, carried me through that was just I didn't want to like not live up to my potential type of thing, I guess. But, whatever. I don't want to get too self-helpy and all that stuff. But I guess that was like the driving force. It's like, I don't want to waste my time on Earth. I want to do cool shit. I want to work with cool people. I want to make tons of money doing that and have a good time. And I'd never want to hate my job. And so in order for me to do that, then I had to get skilled and learn stuff. And that kind of just keeps pushing me forward.
Yeah, that makes sense. Do you think that your strong foundation in mathematics helped you throughout your career?
Yeah, absolutely. Absolutely.
Yeah.
Especially like working with, especially like, in I can't read research papers without understanding the math. So it's like critical. So for sure. Yeah. Yeah.
That makes sense. Okay. And then, so your first programming language was R, and you were using R and SAS?
Yeah.
Okay.
Back in 2008 or not, whenever it was that I was at UC Davis, probably 2009 or 10 or whatever, all the stats classes I was taking at UC Davis were all R. And then I went from R to SAS, like SAS, and then that to Python.
Yeah. Okay. Okay. So R versus Python debate, where are you at with that?
I mean, it's to Python.
How long do we have?
Yeah. No. I use Python. Like everything I use is in Python, right? Like I use PyTorch, like that's in Python. I use Hugging Face transformers, that's in Python. Data sets, that's everything I do is in Python. So I haven't had a compelling enough reason for me to switch to R. If there's people out there doing R, that's great, that's amazing.
Yeah.
But chances are you're not doing R within generative AI or with artificial intelligence or deep learning. Maybe you are, great, like, but I don't see many people doing that. But ultimately, just choose whatever language is going to help you in your career. So
True. Yeah, true. I think that a lot of what I've seen in even myself, because I started out with R, is that's more the statistical, more math focused, right? And then when you get into certain other fields, such as computer vision and yourself, with all of the cool AI stuff that you're doing now, you kind of have to make that transition just because that's the new and upcoming stuff that's coming down the pipeline.
Yeah, because I think deep learning is kind of fundamentally like an engineering discipline. And so Python lends itself to those type of workflows for sure.
Yeah, absolutely. All right, let's get into some fun bets. Hey nerd, are you looking for a career in data? I would absolutely love to help you out. I just launched a data career strategy program that helps folks break into data without breaking anything. I provided a link in the show notes if you want to learn more information about it. Now, back to the fun bits. So I want to specifically nerd out on what you are now considered to be a hacker in residence, because I have a cybersecurity background. So my term of hacker might be a little bit of a different term than your term of hacker. So can you please enlighten me? What is a hacker in residence?
So Paul Graham has this amazing book called Hackers and Painters, which I think is definitely worth checking out. And it's a collection of essays, really, is what it is. And he likens hackers to painters, like they're just creative problem solvers. They're creative people who just get the job done. And then they find ways to get the job done. And maybe they're not doing it with a rigor or discipline, but they accomplish what it is that they need to accomplish. So that's kind of the phrase I use it. So the interesting thing, like at Voxel 51, they're like, hey, you can just pick your title, whatever. Do you want to be machine? You can be a machine learning engineer if you want. Like just pick the title because it doesn't matter because I'll be doing the same work no matter what. And I was like, oh, okay. Well, in that case, I want to be a hacker in residence. That's what I want my title to be. And I got this. There's I think it was like Replicate or something like that had was it Replicate? Yeah. Maybe Replicate. And they had a job posting for hacker in residence. And I was like, oh dude, like that's such a cool like name for DevRel. Because at the end of the day, developer advocate, like the job posting itself like was a developer advocate job posting. But they just called it hacker in residence.
Mm-hmm. So specifically, what do you do? What are your roles and responsibilities?
I'll talk generally in DevRel because it's all pretty much the same thing. So in DevRel and developer advocate, like it really depends on the company and kind of where you are. Like much like data science roles themselves, it's a spectrum. So DevRel itself is a spectrum, but where I find myself on that spectrum is more towards like the education side. Right. So I'm creating educational content, and that educational content can be related to the product that my company is developing, or it could be just generally things that our audience, like the people who can benefit from using our product, are going to be interested in. So that's a huge part of it. Creating educational content, contributing to open source libraries, whether that's expanding our own library through like plugins. Facilitating community members' participation in our open source library, presenting, at conferences and virtual events and things like that, building cool products and projects and demos and stuff like that. So yeah, just just hacking on stuff is basically what I do.
Love it. What types of products or data sets or whatnot do you enjoy working with the most?
Definitely like vision language data sets. So interestingly, at Voxel 51, it's actually a data set company, like in that sense. So the product they have is an open source product called 51. And this is pretty cool. What it allows you to do is it gives you a visual interface for kind of looking through your data. So you can load your data into the 51 app and you can kind of explore it. That on its own is cool. You can overlay labels, you can overlay bounding boxes and captions and stuff like that. But what's interesting is when you start doing take it just one step further, right? Because you could take all of your images and then with those images, you can compute embeddings, right? So you can get the embedding representation, so the numerical representation of that image, and then have, project that into some space. It could be a lower dimensional space through tsne or UMAP. So you're compressing the dimensionality of this vector, and you're just looking at essentially just looking at the points in space, and you can find interesting, cool clusters of things. And it's so cool to see how an embedding model is able to like represent concepts. Like you can have like an island of points, and if you circle in on that island of points, like, oh my god, all those like everything in there is just pictures of pizza. right? So it's cool to see that. So I guess to answer your question, uh, image data, but then also representations of image and text data uh, in embedding space, in latent space. So I guess latent space representation of data is cool to look at.
Okay. Okay. Have you built anything for yourself for at home that you use like on a daily basis?
Not on a daily basis, but like right now, like the big thing that I'm doing at Voxel 51, like they are honing in on my interest in retrieval augmented generation, plus my interest in like multimodal models and vision language models. And I get to hack around with the product to try to find interesting use cases for our product to help in retrieval augmented generation workflows. So what I've been doing lately is I'll curate data sets. So I'll curate like VQA, visual question answering data sets, and then I'll take like a model, any model off the shelf, Lava Next or IDEFX, and I'll run that model on the data set, and then I'll kind of vibe check or evaluate the model. Like, how did it do? Like, what type of questions did this thing get wrong? Or, what type of images cause this model to get the wrong answer. So essentially, like, visual question answering, the way it works is you have an image paired with like a text prompt, and that text prompt is asking a question of that image. And you want to see, can this model correctly answer that question? And you get to, you run that model, and then you start to like kind of, again, move it to a lower dimensional representation. You can take the representation of the question and start looking at clusters of questions that come up, and then you can shade that particular point by the score that the model got on it, and you can kind of look and see, like, are there clusters or are there kind of islands of questions that the model tends to perform poorly on, and if so, what is it about those images or those questions that cause the model to get it wrong? So that's what I've been doing, the last like 2-ish months I've been at Voxel, is just trying to find interesting, cool ways to use our product and to vibe check language, vision language models, pretty much.
Yeah, that's awesome. So it sounds like you have to learn new things kind of all the time, right? You don't know all of this off the bat. So what is your approach to learning these new things? What is your go-to resources?
Documentation, so source code, looking through source code and looking through documentation is always helpful, because at the end of the day, like, I'm not writing anything from scratch. I'm usually working with abstractions on abstractions, whether that's through the Transformers library or through whatever PyTorch 51. And so just looking at the documentation and saying, okay, what arguments does this function accept? What does it output? Getting a sense of that, and then putting things into there, seeing what happens. Like, for example, I was running some code earlier today. It's on this screen right here. I'm just like, I got all these errors. I'm like, I don't know what the hell to do. So I've probably got to go dig into some source code and figure out why I'm getting all these errors. But I think that's probably the best way is, all that to say, get your hands dirty and just start doing things with it. Yeah, it's probably the best way. Just start building with it and hacking.
Yeah. And you mentioned that you read a lot of like research articles. What's your approach to reading those articles? Because I tend to kind of like fall asleep when I read those types of things.
But start by only reading stuff that's immediately interesting to you, or something that you need to know, whether it's for work or some other project that you're working on. So start there. Find something that's relevant to you. And that's step one. Step two, so read the abstract. Once you read the abstract, then read the introduction. Then once you read the introduction, go read the conclusion. Then go back to the top and start looking at all the figures. And once you start looking at all the figures, then go back again, read the abstract, and then start kind of reading the paper itself, highlighting interesting things. And then once you've kind of got a general sense of what the paper is, then take that PDF and put it into a language model and start question answering with the language model, first to see if it's able to extract information that you have the answer in front of you, just to make sure it's getting that information into its context and into the conversation history, and from there just kind of work with it in that sense. If there's code that goes along with that paper, even better, because then you can take that model and you can start doing stuff with it. Or sometimes that paper would just be representing like a data set or a benchmark or whatever. And hopefully that's made publicly available. Go dig through the data set, go dig through the benchmark, start hacking with it.
Yes. Oh, love that. I love
how many
that.
times have I said hack or hacking in the
I'll
last
have to I'll have to
25
count.
minutes? Yes.
So, what else are you working on that you want to share with us? You have books and courses and whatnot.
Mm-hmm. Yeah. So it's been cool working with like LinkedIn Learning. They reached out to me initially like uh, October 2022, I think maybe. And then started developing a course, Computer Vision for Data Scientists. And that course, I'm really, really proud of it. I think it's a really good course. I'm sad only 3,000 people have taken it so far, but I think it's a really good course for people who are data scientists who have like a traditional data science background. Maybe you're familiar working with like scikit-learn primarily, and working with those classical ML models and algorithms, and you want to see what deep learning is about. Then take the course. I'm not saying it just because like I wrote it and I think it's awesome. I'm saying it because I wrote it like from my perspective, because I wrote that course for my like from my journey. Like, okay, when I went from classical ML to deep learning, there's so much stuff that I had to kind of sort out, because there's all this terminology like what is ImageNet, what is ResNet, what is EfficientNet, like what are all these nets? What the hell is a transfer learning? You're saying I could take any model and then I can like take the weights and use it on another data set and fine tune it? And like what does fine tuning even mean? Like what, like, so I approach it from that perspective. Start with like a history of computer vision pre deep learning, working our way up to the deep learning revolution, and then start talking about some of the early fundamental like computer vision architectures. And I stick with some of the more fundamental ones that other people are building on, and then I show you kind of real quick how to use PyTorch, quick like introduction to PyTorch, and then I take it a step further with this library called Super Gradients, where we start kind of fine tuning models and building stuff. So that's one course. The other course I just launched was prompt engineering with LangChain, and that one came out just a week ago on whatever April 17th or 18th of 2024, and within the week over 1,000 people have taken it already. And so that course is just a deep dive into LangChain from like the prompt engineer perspective. So just going real deep on prompts, how to create prompts, how to augment context and stuff like that. And then the other course I'm working on is a hands-on retrieval augmented generation with Llama Index. And so those courses with LinkedIn Learning. Another one that I've got coming up that is going to be immediately after the Llama Index course is text generation with Hugging Face. So that'll be cool. So just talking about different decoding strategies and how to control token selection when working with a language model. And the book I'm writing is on retrieval augmented generation. So practical retrieval augmented generation, but like from like a multimodal first kind of perspective. Like instead of having multimodality and multimodal RAG and cross-modal retrieval being like a chapter in the book, it's going to be like a recurring theme throughout the entire work.
Okay. That sounds all very, very intimidating a little bit for maybe some people that are new to it. So do you have any like recommendations or words of encouragement for those that are kind of new to this space on how they can enter if they really want to get into it?
Yeah, I mean, it may sound intimidating, but I think everything does at first, because you don't know the vocabulary or the terminology. So that probably would be the first place to start, is kind of pick up the vocabulary and the terminology. I saw on LinkedIn, actually, it was Ashwarya, last name started with an N, and she's got like this cheat sheet on her GitHub repo. If I dig it up, I'll send you a link to it. And this is a really cool cheat sheet because it just had like one-liner like definition of all the like terms. So very, very useful. So I think step one, just kind of get familiar with the vocab somehow. And then once you get familiar with the vocab, then you can kind of start taking it a step further. So let me just pause there and give you a chance to kind of because I can go off in weird directions, but I'll pause.
So basically, you're just saying get your feet wet, figure out kind of what's going on with the water in the land, and then you can choose to kind of get deeper and deeper instead of just kind of diving into the deep end.
Yeah, because I feel like people they want to like for whatever reason people are like, oh, I can't just go take a model off of Hugging Face and start working with it. First I need to go understand the math and I need to understand all of this and that. And maybe they hear that because they see people on, pontificating on LinkedIn saying, oh, people these days now they just take the models and then they do stuff, but they have no foundation, blah blah blah. And there's a certain demographic of people that speak like that, and I don't think that's the right approach. I think like a top-down kind of learning is the way to go, especially in a field that's moving so rapidly and so quickly. Because especially with like AI, like there's like a spectrum of roles that you can find yourself on, and I think it's important to figure out where on the spectrum you want to go. So I kind of think of it from far left to like far right, and on the far left is like the people that are actually deriving novel architectures or novel training techniques and actually building the models, right? So, on the far left, you have those people. And then on the far right is you have people who are essentially just, end users who are maybe using this thing as a small piece in their application, right? So depending on where on that spectrum you want to lie, it's going to dictate what type of skills you need to develop and how deep you need to go, right? So if you imagine, like when I say far left of the spectrum, the roles like that I consider them to be like research scientists, for example. Research scientists, I think, is about as far left as you can go. And this is somebody who is like developing novel architectures for these neural networks, developing novel training techniques, and just new ways to build a neural network. Then one step above that, you have like the research engineer, and the research engineer does have that strong technical background, but they're able to take the ideas of the research scientist, work with the research scientist, and instantiate that into code. And oftentimes, research scientist and research engineer might be the same person, but the research scientist might not have like kind of like the strong coding skills. Like they might be able to mock something up to communicate their ideas, and the research engineer's job is to take that and make it more robust. And then a little bit further down from that, you have like maybe a machine learning engineer or a deep learning engineer, right? Who these people are primarily working with models that are going to be pre-trained already, and they have to take this model and specialize it for their particular task, right? Fine-tuning it, or adding some adapters onto it, or whatever, right? They're taking some model and they're customizing it for whatever use case. And then to the right of that, you've got like the AI engineer. And so this is kind of like the delineation of the API line. And the AI engineer will have a lot of the same crossover skills, I think, and knowledge as a machine learning engineer. But maybe they're not like training models from scratch or training models from fine-tuning models or things like that. They're just using the model as a piece of a much larger system, right? Or maybe they're writing the prompts for the models, prompt engineering and things like that. And then even further right of that is just people who are just they don't even want to work with the prompts. They don't want to work with any of like the intricacies of the model. They just want to use it as is. And so that's kind of getting into like the traditional software kind of engineering role, but then using an API with a model behind it.
Okay. That's very helpful personally, because I was having a conversation with my husband the other day because he just got put on a team with an AI engineer, and I was like, what the heck is an AI engineer? So that was a really good summary of like all of that spectrum. So thank you so much for that.
and you'll notice that like I didn't mention data scientist on that spectrum. And I think my view has changed about what it is a data scientist actually is. 7 years ago, like whatever, 20, however long ago, 2017, 2018 was, I think there was data science job descriptions just had everything, right? Like they were just
Mhm.
everything
The
was in there.
unicorn.
Yeah, you had to know Kubernetes, you had to know fast API, you had to know like all the shit, and it's like, dude, no, you don't. You're a data scientist. Like you don't need to know any of that stuff. Like, what are you talking about? Um, and I think this is a very distinct role from like a AI or machine learning type of role. I think data scientists are primarily like I haven't used SQL in ages, right? Like I don't even remember how to write SQL because I haven't touched it in years. And I think you'll find that many machine learning engineers and AI engineers on a day-to-day basis just aren't using much SQL. Like maybe they're using it, but it's not like a driving force of the work that they do, or they're not really creating reports or things like that. Um, so I think, yeah, data scientist, in my view, has changed. Because if you're working with like traditional machine learning models and traditional machine learning algorithms, it's like a completely different workflow than working with, not completely different, but different enough than working with deep learning and generative AI kind of models.
Mhm. Very cool to see that, like, how things have changed throughout the years and the different roles that pop up and the different ways that you approach problems and projects.
Mm-hmm.
Yeah,
Yeah.
that's awesome. Well, Harpreet, do you have any final words, recommendations, encouragements, or any key takeaways to give to the audience members?
So let me qualify this by asking, okay, like who's the typical person listening? Tell me about the typical person listening to this podcast. What are they like? And then I can maybe tailor what I'm going to say to be maximally useful to them.
Absolutely. So, from my analysis and my knowledge, it's folks that are interested in transitioning from their current positions into the data field. So, they're just very new to data, they're very interested in getting into it. So, we talk a lot about those transitional skills and whatnot. And there's probably a lot other nerdy people that already know all of everything that is to data and just are general nerds as well.
Mm-hmm. Mm-hmm. Yeah. So considering that, I think there's a few different routes because I mean data means a lot of things to a lot of people, right? Like when I say data to you, what do you think of?
I mean, information.
Yeah, like does it have a structure? Does it have a format? Like what does like what pops up in your head when you think of data?
For me, because I do come from a financial background, it is a lot of structured relational
Hmm.
database type formats.
Yeah, right. And when
Mm-hmm.
I think of data, like maybe a few years ago, I used to think of that as well, like
Mm-hmm.
tabular data and things like that. But now data is to me, it's like I'm working mostly with unstructured data, right?
Mm-hmm.
Like text data, uh, audio data, image data has some structure to it. You can argue that image data is actually structured data, um, but these type of data sets are different and they're interesting. And I think if you are like me several years ago, when I would think of data, I would only think of tabular data, and I didn't consider uh, you know text or sounds or images um, to be just to be data as well. Like I thought of it as information or something. Like, oh, how am I supposed to operate on that stuff? And that's because I did just this ignorance because I didn't know that I didn't know much about deep learning. Um, and so I guess if you're making that first kind of change from dealing with flat files, so two-dimensional data, to maybe if you want to get into deep learning and AI and Gen AI, depending on how deep you want to go. But I mean, start understanding kind of the fundamental data structure. So that's like a tensor, right? And vectors and kind of understanding what a tensor is and how you can manipulate one and what it represents. Um, kind of start thinking abstractly about these high dimensional spaces because it's weird and you deal a lot with them, and kind of try to wrap your head around this concept of like a latent space and how we can go from a 1536 dimension vector to like a low dimensional projection, and from that low dimensional projection we're able to actually extract out meaningful insights, because we're in this weird latent space. So that's, I think, step one is just wrap your head around that basic data structure. And while you're wrapping your head around what the hell a tensor is, you'll probably end up learning a little bit of PyTorch, which I think is crucial to learn as well. But I mean, you don't have to go too in depth with that. You can definitely just spend a few days or a week, 2 weeks, just kind of reasoning about what a tensor is. Because then once you go there, you can start taking models off of Hugging Face and you can start understanding what the outputs are. Because if you take like an off-the-shelf model from Hugging Face, which you should start getting used to and comfortable interacting with, is the different parts of the Hugging Face ecosystem. And you'll notice that, okay, when I go from raw text to model, the output is not immediately raw text. It's usually some type of vector or tensor. And there's like different probabilities associated with each token and things like that. It's interesting stuff. And you're just better able to reason about what the hell is happening. Like, you're not going to understand it. Nobody understands what deep learning is or how it works. Like, nobody does. It's just a fact of the world. It just works, and we don't know why or how it works. But we still kind of reason about how things are being manipulated as they're moving through a network. So yeah, I mean, I don't know. I hope I didn't sound too like hoity-toity talking about that, but I think it's really important just to start with the fundamental like data structure, this tensor. Start kind of understand it, reason about it, and then from there you'll be able to develop some type of intuition.
That makes a lot of sense. Yeah.
Awesome.
Yeah. Any other things that you wanted to share with the audience?
No, not nothing off the top of my head. Just hit me up on LinkedIn, smash a follow on LinkedIn or on Twitter, and if you have LinkedIn Learning, definitely check out my courses for sure. Got that book on retrieval augmented generation, which I'm really pumped about. So if that's something that you're interested in, definitely check it out.
Awesome. Thank you so much, Harpreet, for coming on the show with us today.
Oh, thank you for having me.
Absolutely. And as always, folks, happy learning.